Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Today we have an additional lecture of marine boilers and steam systems. Today we have 40th lecture and the topic is combustion of fuel, role of nitrogen in air and purpose of excess air. First of all, we will learn about the combustion of fuel. Then we will learn about the role of nitrogen in combustion process. Next we will learn about the need for excess air. Then we will learn about the need for minimizing excess air. Lastly, we will learn about the air-fuel ratio in boiler furnace. Let us learn these through the following slides. Combustion of fuel. What is combustion? Combustion is a chemical reaction between a fuel which consists of carbon and hydrogen with an oxidizing agent, oxygen, usually obtained from air. Combustion is an exothermic process which releases heat. What reaction takes place in the combustion? General chemical equation for combustion of hydrocarbon is given by fuel, that is hydrocarbon, plus oxygen, it gives carbon dioxide plus water. Specific equation for combustion of methane can be represented as CH4 plus 2O2, this gives CO2 plus 2H2O. Stages of chemical reaction. Chemical reaction for combustion of fuel takes place in three stages as explained below. First is initiation of reaction. The combustion process starts with initiation where energy is provided to break the bonds in the hydrocarbon molecules. So we can see here methane breaks up into CH3 and gives hydrogen. Then we have the propagation. Once the initial bonds are broken, the process of propagation involves a series of reactions where fragments react with oxygen to form intermediate products. For methane, a propagation reaction could be CH3 plus O2, this gives CH2O plus H. This reaction continues, creating new fragments and radicals. Third is the termination. The termination phase involves the recombination of fragments and radicals to form stable products. In the case of methane combustion, this process continues until stable molecules like carbon dioxide and water are formed. So we can see here CH3 combines with O2 forms CO2 plus 2H And the final reaction is CH4 plus 2O2, this gives CO2 plus 2H2O. Overall balanced equation is given as shown here. Role of nitrogen in combustion process. Nitrogen plays a significant role in the combustion process, although it does not directly participate in the chemical reactions, forming carbon dioxide and water vapor. The air is primarily composed of about 78% nitrogen, 21% oxygen, and traces amount of other gases. Nitrogen is important in combustion process due to the following reasons. Dilution of oxygen. Nitrogen dilutes the oxygen and acts as inert spectator in the combustion process. Oxygen is crucial for combustion process, whereas nitrogen does not take part in the combustion but occupies space in the air and helps in controlling the temperature of the combustion. Temperature control. Combustion of fuel with pure oxygen can provide flame with temperature around 3000 degrees Celsius, which is difficult to contain in the boiler furnace. Such a high temperature is actually used for either cutting the metal or its welding. On the other hand, combustion of fuel with air provides a flame temperature of 1500 degrees Celsius, which the refractory can withstand without distortion or failure. High temperature generated during combustion can lead to the formation of nitrogen oxides, which are pollutants. The presence of nitrogen in the air helps to regulate the combustion temperature, preventing it from reaching excessively high levels that could promote the formation of these nitrogen oxides. Stoichiometric consideration. The air-fuel ratio is crucial for complete combustion. Nitrogen is included in the ratio calculation because it occupies space in the air, affecting the overall composition of the mixture and influencing combustion efficiency. Stoichiometric requirement for various fuels used on the ships has already been discussed in the lecture number 36. Need for excess air. In a boiler furnace, excess air is the amount of air supplied to the combustion process that goes beyond the amount theoretically required for complete combustion of the fuel. Main reasons for maintaining excess air in a boiler furnace are discussed below. For complete combustion, excess air ensures that there is enough oxygen available for the combustion of all fuel particles. This helps in achieving complete combustion, where fuel is burned completely to produce carbon dioxide and water vapor, minimizing the formation of harmful pollutants like carbon monoxide. For temperature control, excess air is used to control the combustion temperature. It helps to prevent the temperature in the furnace from becoming too high, which could lead to the formation of nitrogen oxides, which are harmful pollutants. By regulating the amount of excess air, Combustion temperature can be controlled within the desired range. For safety, maintaining an appropriate amount of excess air is essential for safety. Insufficient air supply can lead to incomplete combustion, resulting in the formation of carbon monoxide, a highly toxic gas. Excessive air, on the other hand, can lead to operational inefficiencies and energy losses. Need for minimizing excess air. While excess air is necessary, it is crucial to keep it to a minimum for following reasons. Efficiency. Excessive air can lead to heat losses and reduce boiler efficiency. This is because a portion of the energy is used to heat the excess air rather than contributing to the heating of water and or steam. Energy conservation. Minimizing the excess air helps to conserve the energy by ensuring that more of the heat generated during the combustion is utilized for generating the steam. Compliance with environment. Excess air can lead to incomplete combustion of fuel, resulting in increased emissions of pollutants such as carbon monoxide, nitrogen oxides, and unburned hydrocarbon. These pollutants contribute to air pollution and can have detrimental effect on human health and the environment. Incomplete combustion due to excess air can also lead to formation of secondary pollutants such as particulate matter, volatile organic compounds, and hazardous air pollutants. These pollutants can have adverse effects on air quality and human health, as well as contribute to environmental degradation. Thus, it is important to strike a balance between performance and compliance with environment by optimizing the amount of excess air based on specific characteristics of the fuel being burned and the design of the boiler. This is often achieved through careful monitoring, control system, and periodic adjustments to ensure both efficiency and environmental compliance. Air fuel ratio in boiler furnace. Factors on which air fuel ratio depends. Air fuel ratio in boiler furnace is very crucial for efficient combustion and depends on type of fuel, combustion equipment, and operating conditions. Typical range of air fuel ratio. The optimal air fuel ratio is around 15:1 to 16:1, which means 15 to 16 parts of air for every part of fuel. However, this can vary based on specific type of fuel and combustion system. This ratio includes about 10 to 20% excess air in the stoichiometric air fuel ratio. Purpose of excess air. A certain amount of excess air is usually provided to ensure a complete combustion and to account for variations in operating conditions. How to find air fuel ratio for a specific boiler? Boiler manufacturers carry out comprehensive tests on the combustion of fuel in boiler furnace at various loads and document the most appropriate value of air fuel ratio in the boiler's instruction or operational manual and provide the boiler performance curves. This completes the study of combustion of fuel, role of nitrogen in air, and purpose of excess air. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship boiler safety. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notifications about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching till the end.